Okay, so we're looking at these triangles. The topic this evening, like we said, is similar triangles. And when we say something is similar, it means we can pick out some resemblance, between such items. In this case, we're looking at triangles. So we can see that the sides are the same or are similar because this, in this case of ABC, triangle ABC, the two sides are the same. In the case of triangle Z, Y, XYZ, sorry, this is supposed to be XYZ, XYZ. These two sides are the same and the base angles are the same. So this is an isosceles triangle. All right, so we'll be right to say that the relative sides of this triangle, most times what we do here is that we work with the ratios of the relative sides of the triangle. So we can say that we can take the ratio of AB because we know that AB, we can relate AB to XY. We can relate AC to XZ. We can relate BC to YZ. So these are the relativities, right? And this is what makes them similar. But this is very important because so many equations will be coming out in your exams and you'll be expected to find the missing sides of this kind of triangles, and you'll be expected to apply these ratios to be able to find the missing sides. So you take advantage of the relationship, take advantage of the sides that are given to find the sides that are not given. All right, so now I'm going to clean this and take an example. Let's clean this and take an example, for instance. So let's say we have this triangle here, and there's a parallel line here to this, and we have A, B, C. Then we have Y, Z. All right, so these are two triangles, one smaller triangle embedded inside the larger triangle. So we can pick out two triangles here. We have two triangles, triangle AXZ, sorry, AYZ, AYZ, and triangle ABC. So these are the two triangles we can find here. All right, so now if we want to relate this in terms of the ratios, we can actually say that the ratio of this smaller triangle AY will be all over that of the larger triangle, which is AB. So if we're going that way, we're going to have it that AY all over AB, then AZ all over AC equals to, sorry, YZ all over BC. So that's what we're having here. All right, so good. So what if you're asked to find the sides, and maybe the side of this triangle was given as 6, and the side of this was given as 6, and this was given as 3, and you're expected to find x. You're expected to find what? X. You can apply this to this triangle to find x. So if we're to do that, we're just going to take advantage of what we have. Already take note that this side had been given, which is the final side, the last side. That's BC, and YZ has been given. Then also we're given AY, but we're not given AB. So let's see how to relate that. Okay, so AY will be what? 6 all over what? AB. AB is going to be what? Distance from here to here, or the dimension from here, the linear dimension from A to B, and that will be the dimension from here to here plus the dimension from here to here. So since we don't know what we have here, it's going to be 6 plus x equals to. Then I'm going to take advantage of what a known value in this triangle. The known value I can equate this to is this other side of the triangle. So I can say equals to 3 all over what? 6. So these are the relative sides I can work with. So if that is the case, it's going to be, I'm going to multiply this and multiply this. So it's going to be 3 times 6 plus x is going to give me 3, 6 plus x equals to 6 times 6, that's 36. 3 times 6 is going to give me 18 plus 3x. So 3 times x is going to give me 3x equals to 36. Okay, so now I'm going to take my like terms, or I am going to subtract 18 from both sides. Subtract 18 from both sides. So when I do that, it's going to be 3x equals to 36 minus 18. That will be, let me continue here. That will mean 3x equals to 36 minus 18 equals to 18. Then I'm going to divide both sides by the coefficient of x here, because what I'm looking for is what? X. So if I'm to do that, I'm going to divide both sides by 3. So this 3 will cancel out, and we have x equals to 18 divided by 3 is going to give you 6. So with that, we've been able to find x, and it simply means that, therefore, AB, if we're to find AB is going to be what? AB will be equals to what? 6 plus 6, that's 12, equals to 12. So it's just a very simple way of applying the principles surrounding similar triangles. And I want to believe this explanation is very clear for students who are preparing for the exams, the final year exams, SSE exams, GCE exams. So you can lay your hands on other examples as well in similar triangles and try addressing some issues there. And also, I would appreciate it if you just drop, your comments in the comment section regarding any challenges you're having, and also share the video and then follow us for more educative content. Thank you very much. See you in